A customer taps pay once. Their statement shows the charge twice. You go looking for the bug, and here is the uncomfortable part. There isn't one. No exception, no failed request, nothing in the error log. Every component did exactly what it was built to do, and the customer was still charged twice. This happens because of one property almost every distributed system has, and almost no tutorial mentions. The network can lie to you about whether something worked. So let's design a payment flow that cannot double charge, and see why the fix is smaller and stranger than you would expect. Start with the obvious design. The client sends a charge request to your API calls the payment provider, the provider charges the card and returns success. Simple enough, until the response doesn't come back. The provider took the money, and then the connection dropped before the confirmation reached you. Now your service is holding a timeout, and a timeout is the most ambiguous signal in distributed systems. It does not mean failure, it means you don't know. So your service does the sensible thing and retries, and the provider, seeing a brand new request, charges the card again. Now, the mistake here was not the retry. Retries are how you survive a flaky network, and removing them makes the system worse. The mistake is that the second request was indistinguishable from the first. The fix is to make the request carry its own identity. Before the client sends anything, it generates an idempotency key, a unique value representing this one attempt to move money, not this one HTTP call. The key travels with the request, and your service stores it alongside the result. When a request arrives, you look the key up first. If you have never seen it, you process the charge and record the outcome against that key. If you have seen it, you skip the work entirely and return the outcome you recorded the first time. The retry now gets the same answer as the original, and the card is charged once. There is one detail that decides whether any of this works, and it is the part people get wrong. The key must be generated when the user forms the intent to pay, not when the client is about to send. Generate it inside the retry loop, and every retry invents a fresh key, and you are back to double charging with extra steps. Now the second order problem. Because the first fix creates one, two retries can arrive at the same moment. Both look the key up, both find nothing, and both decide to charge. So the lookup and the write have to be a single atomic step, not two. In a relational database, that means a unique constraint on the key, with the record inserted in the same transaction that records the charge. The loser of that race gets a constraint violation instead of a second charge. There is also a decision about what you store. Storing just the key is not enough, because the retry needs the original response, not an acknowledgement that something happened. Store the key, the result you returned, and a fingerprint of the request body. If the same key ever arrives carrying different content, that is a client bug, and you reject it rather than quietly returning the wrong answer. Put together, the shape is small. The client generates a key at intent. The API rejects any charge request that doesn't carry one. A store of keys and their outcomes sits in front of the payment call, written transactionally. And underneath all of it, a ledger, an append-only record of every movement of money, where you insert a new line rather than update a balance. That last part is the one people skip, and it is the one that saves you during a dispute. If the balance is a number you overwrite, the story of how it got there is gone. If the balance is the sum of every line ever written, the story is the data. So when the customer calls and says they were charged twice, you are not guessing. You can point at the exact request, its key, and the single ledger entry it produced. That last idea, that the record of what happened is more trustworthy than the current state, is not a payments trick. It is a whole way of building systems, and it has a name. If you want to see it applied properly, with projections, RID models, and the parts that get genuinely hard, the Event Sourcing and CQRS series builds a full financial ledger from the ground up. That is where to go next.